All right, we are here and we're doing the daily space weather. Got to put on the shades when staring at the sun. Currently doing so on 171 angstroms. And by the way, thanks for tuning in, everybody. We see very low levels of solar activity. We see no sunspots. Coronal holes a little north of the equator there. A little bit of magnetic activity down here in the south. Let's have a look up close. That's the most magnetically complex region on the Earth-facing portion of the disk. A little bit of filament activity down here in the southeast as well. Here's a northern portion before we move on to have a look at 193 angstroms. We do see a few bright spots in the North Pole coronal hole region, as well as down here by my pointer. And here's the 193 angstroms view of the same area. And here's the south in that wavelength. So the sunspot space age record was broken. 271 days. So yesterday was the longest stretch we've ever seen during the space age without a sunspot. So that's a new record. The old record was in 2008 to 2009. Now the next thing to watch, by the way, folks, is cosmic ray flux. We are hoping it does not get as high as it did back here in 2009. And it's something to keep an eye on. And when I say eye on, the pun is intentional. Another measure of solar activity besides sunspots is the 10.7 centimeter radio flux, as the corona emits radio frequency very similar in graphical intensity to sunspot number. So it's a very similar proxy, which is why we look at the 10.7 centimeter radio flux, especially at solar minimum. Current reading is at 70 solar flux units. Let's look at cosmic rays as we haven't for a couple of days. Here's apatity, and we see an uptick at apatity over the past 5 or 6 days, although flat on the 30-day average. Barentsburg looking flat, period. Next we'll look at Athens. And by the way, folks, I am able to see the chat room today if you're watching on Twitch Live. And if you're watching on the YouTube Premiere, I should be in the chat room there as well, as I am not only smAsho, but I'm also a client. There's the Athens neutron monitor, pretty flat over the past 30 days as well. Next we'll look at Mexico City. By the way, you can look at archive data on Mexico City. It'll be a little jumbled up on the graph, but anyway, that one's similar to apatity, actually. Small uptick over the past 5 days, flat on the past 30 days. Next we'll look at Moscow, which has shown some drastic spikes and some old data. And Moscow back to not returning data here for the last few days, and some wild swings, but flat on the past 30 days, at least as far as data that's been returned. And last we'll look at Oulu and Antarctica DOMC. And there's Oulu, Finland. Pretty pretty flat in the past 30 days also. Highest point there was on December 8th. And here's DOMC Antarctica. And we would oblige to show you DOMB Antarctica, but it's not returning data. Links to the Network of Cosmic Ray Stations site below the video in the description. Next, we'll check out the GOES electron flux, which is very low levels, as we've seen very low levels of solar activity for the past solid 2 weeks. And nothing even resembling a plage, much less a sunspot, for quite a while. So let's look at the total electron content forecast, as we haven't done that for a while on the channel. And we used to cover this daily. This will show you where your GPS errors are anticipated to be. Keep in mind this is the forecast. And you'll see only fairly small GPS errors expected even around the equator at noontime. You're getting into about 30-meter GPS error there if you're around Hawaii at noon. Otherwise, GPSs will be working pretty darn good. And relativistic electrons are remaining at a low level. And we're not going to get into the physics of why that is, although I will cite the fact that I'm able to forecast it now after pouring through lots of data for hundreds and hundreds of videos. The GOES magnetometer, I got a forecast for that too. It's going to remain sawtoothed and spiky for the next 3 days, at least 2 days. So watch as this jumps all over the place, especially tomorrow and on the 20th. Here's the data from Gong 2, and that's what is eliciting my forecast. You can see these field lines are all over the place, right at the polarity crossing. Stereo A, which is located here on the ecliptic plane there. It's about 3 months behind the Earth in terms of orbit, but it's able to see space weather first, which is why it's stereo A for ahead, not to be confused with stereo B for behind, which is ahead of us orbitally speaking, but it's seeing older space weather as the sun rotates faster than the Earth does around the sun. Let's just put it that way. Anyway, stereo A, you can see its field lines are a little bit undecided as to what they're doing there. So some oddities happening there. But more importantly, the Earth's field lines are about to suddenly snap here. Any small changes with the polarity of the North Pole, or with the power of the North Pole, the North Solar Polar Field. If it suddenly diminishes in power, or if the Southern Polar Field increases in power, it could speed up this polarity crossing here. So we wouldn't be surprised to see that within the next 24 hours. Although again, we see magnetic anomalies out here as recorded by stereo A, so we expect to see continued spikiness in the GOES magnetometer graphs. Next, we'll look at the real-time solar wind, and we see a phi angle of 295 degrees, indicating no real magnetic connection with that coronal hole, although we did see one back here around just before midnight there. Actually, not just before midnight, at about 1:23 UT. A lot of numbers on the screen, folks, a lot of numbers. We also did see some spikes in the plasma density here. We saw it hit all the way up to 44 protons per cubic centimeter and then 30, but still very low levels of activity. 4.8 is the current proton density. And solar wind speed still at 347 kilometers per second there. So small ramp down in the speed, small ramp up in the solar wind density, very low levels of activity, period. So not only is the sun at a low level of activity, so is the solar wind. There is a coronal hole wind stream on the way. And that brings us to timeanddate.com, where we ask you, what are you doing Saturday night around 11 p.m.? We'll be doing a live stream from 11 to 12 to roll in the winter the correct way. and look at a bunch of astronomical data at the same time as the solstice hits. So, always interested in astronomical events on the channel, so we'll be live streaming during the solstice. And don't worry, folks, we'll create another completely separate video for the daily space weather for you. Here's the geospace magnetosphere movie depicting magnetohydrodynamic pressure, which you'll see is at very low and fairly steady levels. Now, if you would have been viewing this during those big increases in the solar wind density, you would see big spikes in this. But the last 4 hours don't include anything like that. Next, we're going to look at ground geospace magnetic perturbations. And you should see a small uptick in induced current here right at the end of the video. Just the final couple of frames, you should see a small uptick, as when the magnetosphere is very weak, a small uptick in the solar wind density makes a big difference in induced current. Let's get that back to where it was before it refreshed automatically. And by the way, you can sit here and watch this thing all day long. Not a very big spike there in pressure at all, or in current, I should say. Or let's just say magnetism. Anyway, here's 6 hours of data from the ionosphere. And by the way, we're looking at Australian Government Bureau of Meteorology's site. And you can see nighttime charge-ups over the South Pacific, as we've been documenting for several weeks. So you're going to see a massive charge disparity here. When the energy around the South Atlantic anomaly rotates around to the South Pacific, you're going to have a huge charge disparity in this area here, causing some ionospheric turbulence south-southeast of Hawaii at nighttime. And it's been looking pretty similarly for the entire past 3 weeks or so. KP index back up to 1, following 12 hours at 0. Part of the reason why we covered the cosmic rays. And we see a serious earthquake swarm here south of Alaska, but otherwise no 6+ magnitude quakes. Hey, David Devine, did you feel that quake? 4.9 magnitude at Taiwan. Not sure if you're at Taiwan right now or not. Please leave a comment. And what did the cops say when they knocked on your door? Be stoic, what did they say? As you probably wondered why you were being invaded. So we see a deep quake here coming into Indonesia. That's a 4.6 magnitude at 207 kilometers. This could be the largest of the past 24. That one happening in Indonesia at a 5.6 magnitude. So we see an increase in quakes around Oceania and Alaska. No quakes around South America. And let's just scroll up the list here. Here's a deep quake at Japan, only a 4.6 magnitude, 114 kilometer depth. And here's a very deep quake near Fiji. That one's a 5.1 magnitude. If that happened at the surface, that would be nearly a 7 magnitude quake, as that one happened at 542.4 kilometers depth. We also see a quake 29 kilometers east-northeast of Redoubt Volcano in Alaska. And that is a deep quake. Heads up Alaska. I don't want to see any tsunamis trashing Alaskan ports, please. And let me just scroll up the list here as we move on to a lot more stuff. Such as this deep quake in Indonesia. That one coming in at 6:53, just a couple hours before we shot the video. It's 5:14. Do you know where your earthquakes are? All right, let's continue on here to look at the windy.com pressure maps and current conditions. We'll let that advance via the GFS model. And there's where things will be in about 24 hours. We're getting inundated on the eastern U.S. right now. By the way, some deadly tornadoes hit the southeastern U.S. We'll get to it in a moment. First, volcanoes. Mount Aso, possible activity. Please don't set up a campsite on Mount Aso. Sakurajima, flight level 7,000 there. Sanjiang Api exploding. Flight level 8,000. Tokono, flight level 7,000. Fuego. Not sure on that one. Probably a cloudy day obscuring the volcano from the satellite. Sangay in Ecuador exploding. 20,000 foot ash plume there. Revenador exploding. Flight level 15,000. And Sabancaya continuously emitting volcanic ash and gases. No flight level listed for Sabancaya. Here's where stuff is in the solar system. Here's where stuff will be in 1 week. Looks like about 1 day before the new moon. On Christmas Eve. It's going to be a new moon Christmas, it looks like, folks. How about that? And if you've got a low horizon in the east coast of the U.S., for instance, go check out Mars. It's just rose. It's just risen. It has just risen. So if you've got a good view of that, go check it out. I like to use in-the-sky.org's sky map, which is animatable, by the way. If you want to check it out yourself, just put in your location. Go to charts. Click on all sky charts. But there's a lot of other interesting features at in-the-sky.org if you want to make yourself a living chart. And just talking about what I was talking about here when I said the cops knocking on everybody's door. Bestoic says 4 a.m. cops just knocked on every door in the apartments. As they need a reason to do things like that. Probably just looking for a fleeing criminal. Wondering if he just entered into a building randomly and sought refuge in an unlocked apartment, perhaps. This is why not to leave your door unlocked for Kramer. By the way, we're also on BitChute as we archive our videos there. And thanks to our new subscribers on all platforms. So yesterday we had some tornadoes sweep across the U.S., killing at least 2 in Alabama and 1 in Louisiana, causing general havoc. I don't really see any photos or anything, just reporting what happened here via Reuters India. It looks like I'm in for some reason. I don't know why. Looks like Reuters India. And I have no idea how I ended up there. Let's go back to the Reuters US. Reuters India. Anyway. By the way, there are some power outages continuing. It's last I checked, as it looks like Mississippi's got 10,312 people out of power. And there's a lightning maps. Current lightning situation is to be seen before you. And we're seeing some wintry mix over north central PA. Some snow in the northernmost reaches of Pennsylvania. Wintry mix over northern New Jersey. Don't drive into a freezing rainstorm, folks. I did it last Sunday, and I turned around and was not pleased. It was the Sunday before this past Sunday. The Sundays are the first day of the week, so Sunday is the thing. Anyway, let's zoom in on the most intense part of this area, which looks like it's around here, around Alabama, just to see what's going on there. Doesn't look too extreme. Let's move on to the water vapor map. And there's what's going on via the NASA GOES. I don't know which one it is. NASA GOES East, wavelength 6.19 nanometers. Looking at the water vapor. And also, hey, thanks new subscribers on YouTube. By the way, we've recently gotten over 100,000 views. So thanks for that. Man, we got some turbulence over the central U.S. Let's take a quick look at what's going on over Kansas. Please leave a comment if you think tornadoes normally happen on December 16th in the U.S. Looking at some pressure gradients, folks. And let's just move on, as we don't want anybody to get too excited about weather pornography. Here's the jet streams of the Western world. Massive anticyclone over southwestern Greenland, as well as a huge bend here over Gibraltar, really. The bend is basically right over Gibraltar. Check it out. 180-degree bend over about, what, 90 miles maybe? Incredible jet streams. Please leave a comment if you've flown a plane and understand what I'm talking about. Here's the Eastern Jets, and let's move on to more stuff, such as welcoming our viewers to the Neo-Renaissance. Check out smAsho.org. Forum is coming too. I'm learning how to speak the English language. And the forum is coming soon. And we don't have it linked yet, but nonetheless, you can check out our mission there, for instance. Just go to smAshomash.com/forum/mission. And you'll see a graphic and it'll totally make sense. Anyway, we will be having people set up logins and so on so we can have discussions on our own servers and not have any kind of interference from certain obnoxiously annoying organizations who own most of the servers on the planet. Speaking of the devil does evil. Don't be evil. And please press like and subscribe if you enjoy the content, wherever you're viewing it. And please support the channel via Patreon. That's patreon.com/smAshomash. As we've got a lot more stuff to do as we punch up massively. And recommend our viewers stay tuned for even more bonus features. Are you aware of what's going on in the center of the Milky Way? Let me just play a quick. There's a lot of very massive objects rotating around at very high speeds, indeed relativistic speeds, toward the center of the Milky Way. And one of them is called S2. Now, we've been doing a segment every day about fast things and slow things. Let's talk about some things that are even faster than the Parker Solar Probe. These massive stars are orbiting Sagittarius A star, the massive radio source at the center of the Milky Way galaxy. You know that one. At significant percentages of the speed of light. Let me play another portion with an expectation of not being banned or demonetized due to fair use, since we talk about cosmology every day. Anyway, there's a lot of things rotating around the massive radio source at the center of our galaxy at very high speeds, and most of them are very massive objects. And there's probably all kinds of other objects there too that we cannot see because they're obscured by things like dust, magnetic fields, etc. As well as plasma. Yes, ionized plasma. Anyway, S2 was believed to be the closest star to the massive radio source known as Sagittarius A star, with an orbital period of only 16 years, similar to the orbit of Jupiter. But this thing is going at a ridiculous speed. And if you want to hear about the orbit, it's calculated at going 11 million miles per hour, or 1/60th the speed of light. So that's, let's just say there are some tidal forces involved. And if you want to read about S2, we've left links below the video. Were you aware of S102? Well, it turns out there's an object even closer with an orbital period of only 11.5 years. And again, it's orbiting the massive radio source known as Sagittarius A star, even closer, as it's only 260 astronomical units, otherwise known as the distance from the Earth to the Sun, from Sagittarius A star. And again, it reaches over 1% of the speed of light. This was only discovered in 2000 it looks like. It looks like it was realized to be the shortest period by 2012. So if you want to read about S102, we've linked that also below the video. Now, there is a UCLA Galactic Center group, which you may want to follow also, as they've been measuring the positions of many, many objects in the vicinity of the Sagittarius A star for more than 20 years. So check that out also, as these massive radio sources, they're kind of important in cosmology. They're associated with the motions of galaxies, so we're very interested in how they work, what they're made of, and things like that. Let's go to a Universe Today article. Oh, it's a phys.org article. I stand corrected. Anyway, the Very Large Telescope in the Atacama Desert in Chile, I believe it is, has produced some fantastic images of the galactic core. And let's play a clip. I don't know if there's sound or not. Let's see. Looks like there's no sound, but it's a very close pan. So we've linked that article as well. Some very close composite images available for you there, if you want to have closer looks. By the way, some folks are concerned if there might be a second supermassive radio source at the center of the galaxy, which some astronomers will refer to as black holes. Now, it's fairly evident that there are no massive radio sources with a calculated mass of 100,000 times the sun or more. However, there might be one in the sort of intermediate black hole stellar range. And so some folks are looking for it. A gentleman by the name of, well, I have no idea. Let's scroll to the end of the article. Probably Smadar Noaz, Associate Professor of Physics and Astronomy at University of California, Los Angeles. Anyway, there'll be some in-depth studies coming out soon about the motions of these objects. Based on what we've seen, my colleagues and I show, and this is a quote, by the way, this is not me saying this, this is the author. Based on what we've seen, my colleagues and I show that if there is a friend there, it might be a second black hole nearby that is at least 100,000 times the mass of the sun. I thought they were looking for an object less than 100,000 times the mass of the sun, but hey, what can you do? Now, there's been a very close flyby of Phobos. So for all of you folks out there interested in the features on Phobos, I know it's a very interesting satellite, as it's kind of oddly shaped, to say the least. And it's got some fairly obvious electrical scarring type features on it. Here it is being phased with some fantastically high-res views. We've linked this article also below the video, so have a read and a watch. Oh yeah, Phobos. Phobos in its full glory. So we've left links to this article courtesy ESA. ESA.int. Good times. As I know there's a lot of people interested in the electrical scarring features. Now, Rolf Vishay has come out with 4 videos in the past 2 days talking about plasma, plasma, plasma. And if you'd like to hear some of Rolf's work about extraordinary evidence in plasma astrophysics, rivers in space, as well as holes in the sun, have a listen. And we're looking to get you on the show pretty soon here. Rolf, please drop us a line. I heard you watch the videos. Let's get to some alternative theories, and whether or not they conflict with each other is the subject matter for a different program. I just wanted to cite to our viewers that we have emailed Dr. Robitaille. Let's hope we get a response so that we can talk to the source of the liquid metallic hydrogen model of the sun, Dr. Robitaille himself, and get him on the show to talk all about not only this paper, but more importantly, the implications to this theory on cosmology. Does it add tools to the cosmic toolbox? Does it subtract tools from the cosmic toolbox? And how does this relate to the galactic and the earthly scales? So those are going to be the subjects when and if Dr. Robitaille responds. And we are super excited about the possibility of having him on the show where he can talk about things like lattices and intercalate layers and why coronal holes happen and what sunspots are and why the solar wind accelerates and a million other brilliant pieces of information explaining the observations in a reasonable fashion of the data that we see coming out of the sun, shining brightly right in our faces and saying, "Hi, here I am. This is how cosmology works. Please don't use ridiculous cartoons and math in search of observations to determine the mass of a star in a different galaxy, as that's a ridiculous notion." Now, let's talk about Westerhout 5, otherwise known as the Heart and Soul Nebula. We've left links to this interesting emission nebula below the video in the description. So check that out if you like. Here's a gigantor image of it. And shout out to Terry Hancock. Well done. Nice image in there, Terry Hancock. I won't misgender you by suggesting you're a Mr. or a Ms. Let's do some close-ups. I'm not sure if that's the heart or the soul. I think that's the soul. And that certainly looks like the heart to me. It is inverted. Here's the pointy part. See what I mean? Anyway, we've linked to that image also if you'd like to put that on your desktop. Were you aware that there is indeed another tool just recently added to the cosmic toolbox? Guess what it is? Electrical polarization, folks. See those? Those are strings of glass beads in microgravity. And guess what happens? They align into these long strings because they polarize each other and act like magnets. Were you aware? Do you watch our videos every day? Did you believe us when we told you over and over again that astrophysics and cosmology are being rewritten, and indeed physics in general. So it's a great time to be involved in science, folks. And thanks for viewing the videos. This Universe Today article is also linked below the video. Turns out that planets started from dust clumping together, but not because of gravity. See, if you just have gravity, things just bounce off of each other. But guess what happens? Particles develop strong electrical charges, so strong that they polarize one another and behave like magnets. As practically everything is charged up in space, as there's a lot of ionization and not a lot of ability to ground the particles, let's say. So anyway, it's a fantastic article, and it's an ungrounded particle. So continue to tune in as astrophysics and cosmology get rewritten, and the implications of all this stuff get stretched across the entire universe and confuse the heck out of physicists, cosmologists, astronomers, etc. Let's talk about synchrotron radiation. Oh, what's synchrotron radiation, you're wondering? Synchrotron radiation is something that we see coming out of certain things, like astrophysical jets. And the thing to understand about synchrotron radiation is that synchrotron radiation is caused by particles which are charged being accelerated in a curve around a magnetic field. And when the electrons do that, well, they emit radiation across the entire electromagnetic spectrum. Now, what are the implications of this on cosmology? Well, they're kind of important, as we see synchrotron radiation coming out of astrophysical jets, such as quasar jets, galactic jets. There are undoubtedly synchrotron radiation emitting portions of the core of the Milky Way, for instance. And the thing to understand about synchrotron radiation is, while all you really need is electrons changing energy state, electrons don't just follow nothing around through space. You need to have magnets, magnetic fields. So now, the thing about plasma to understand, folks, is that yes, plasma is ionized gas. Plasma does block the viewing of magnetic fields from a distance. What plasma doesn't do is emit strong, steady magnetic fields. Why not? Because if you apply a magnetic field to a bunch of ionized gas in space, all it does is heat up the gas. The gas doesn't turn into a magnet, folks. That's not the way it works. So we need to have condensed matter in order to have stable magnetic fields, and that's what I'm getting at here. We see synchrotron radiation when we see electrons moving at relativistic speeds, or even ultra-relativistic speeds, around a magnetic field. Those fields don't just hang out. There is a reason why those fields are there, and let's just leave it there for now, as we've got to get the video produced in various other locations. If you're not following us on Instagram, please do so, as we put various material on there where we cite all kinds of things, such as this lovely moon set just a couple of days ago. See that? We cite the fact that Michelle Wolf is quite funny, despite being a white supremacist. See, she's holding up the white power symbol here. Yeah. Just kidding, folks. You realize that the Defense Department is actually investigating Army and Navy academies for white supremacism because of this. What is it? This? Because of this. Yeah. It means okay, folks. Okay? Okay? Trump called. Trump said it's okay to say okay. Okay? Good God. Let's talk about grudges. The definition of insanity is holding a grudge. And holding a grudge, well, let me use it in a sentence.
Grudge.
Holding a
grudge
is equivalent to consuming poison and expecting the other person to die. Thanks, Smash Team, for tuning in. Stay tuned for a one, count 'em, a bonus, a feature. It's the local yellow dwarf, I think. And it should be in 94 angstroms. We're going to wait patiently. And then I'll impatiently hit refresh. Anyway, there's the 94 angstroms view. And we're looking at 48 hours of solar activity, folks. Save the date for Saturday night, 11 p.m. to midnight Eastern Time. We will be streaming live for the solstice, which happens just after 11:19 p.m. Eastern Standard Time. We are out. Don't forget to stare at the sun. Don't forget to not drive. Don't forget the fact that it's never going to be now again. Welcome to the Neo-Renaissance. And may that solar wind be at your back and that atherosclerosis absent from your veins.